Okay, welcome, Joy and Tammy, and all you watching this as an archived lecture. So the bigger question is, what are we going to do today? And there's a big topic this week, big as in really important, and that is regression analysis. It's one of those that comes up. It's one of those that comes up both in research, like hardcore research, and also day-to-day stuff. You'll see it. And there's a lot of faulty regression analysis, and I'm going to go over some of the mistakes people make. You know, and people meaning like sometimes in big news articles will make mistakes just because they don't understand it well enough. And there's also some great things that happen. So the other thing is a big reminder, Sunday. What's due on Sunday? Besides regression analysis assignment? Yeah, project 2 is due on Sunday, and that's a big part of the grade, also a big part of the learning, really important for the understanding the final. So if you work hard on project 2, then that gives you a boost for kind of learning the stuff that you have to know for the final. So just to note, I did a few things. One, I'm not sure, Joy and Tammy, did you see my announcement I made about an hour ago or so? 8:50. Yeah, so what I did is I put, because this was because on the midterm when I asked what do you recommend me do, that was one of the things you guys wanted as an outline. So I decided that this was a good time for an outline, a full outline. So I put a full outline of things that I expect. And by the way, that outline is ordered. Okay, most of it's strict. The only things that you can switch are confidence interval hypothesis test, could be either direction. But otherwise, an outline is really important. So by Wednesday night or Thursday early morning, if you want me to read through your draft, you need to have it submitted by then. Just a couple notes. Saturday, I will be offline pretty much the whole day. Not to like be mean to you guys or anything. Yeah, so Wednesday night is when I'm hoping to get all the projects so that I can read through them Thursday and give you ideas on how to improve. Saturday, I'm going to be offline pretty much the whole day. There's a conference I'm going to. I'm actually speaking at the conference, so I kind of need to focus on that, and I can't do much with you guys. Sorry about that. But I will be online Friday during the day, and then back on Sunday too. But Sunday's a bit late to be asking questions about the project. You really want to be doing that earlier. So just note, post all of your questions on the project discussion forum for project 2, the project 2 discussion forum. And also just general problems on Q&A. The other thing that's happening in 16 days or earlier, any guess? Yeah, that's the final exam. So really important that you need to let me know who I need to send your final exam to. And you can let me know early next week or this week, but don't wait till after that. And if it's the same person as I sent your midterm to, then it's really easy. Make sure you tell them that you're going to take it and make the arrangements, but I can do that. If it's a different person, you just got to give me all the full details. And there is a final exam information quiz, just like I had one for the midterm, that you have to fill out or lose 5%, and that would be ugly. So a couple things that are coming up. There's big stuff coming up. We only have 2 weeks left of class, so this is the time. Are there any questions about anything? Any questions? Okay, I think I'm going to get into regression analysis. Today is not one of the longer days, so most people like that, but it is one of the real important days in terms of lifetime importance, things that you will use and read throughout your life, for the rest of your life probably. You're going to see it from time to time. So I'm going to bring about the most important thing in my area. And Tammy, you used to live in Tahoe, right? And Joy, I'm trying to remember. You ever been to Tahoe? Okay, you never been there? Okay, so Tammy might have a chance. What's the most important thing people collect data on and analyze in our area, in my area? Yeah, Lake Clarity. So what I thought I would do is I'm going to tell you a little story, and it's going to be a story with a picture. The cool thing is one of my students was there, and so was the President of the United States. So that's pretty important, in Tahoe, by the way. And so were like our senators and there were Congress people. It was a big deal. It was a long time ago. Any guess on what president I'm talking about? Yeah, it was Bill Clinton. Were you around then, Tammy? Here? Okay, you read about it. Okay, you probably didn't hear about it this way, though. Okay, and I heard from my students, I know this is true. One of the things they showed, what they did is they presented to Bill Clinton about Lake Clarity. Okay, I was last living there in 2008. Yes, that was way before 2008. Okay, so they presented to him about Lake Clarity, and one of the good things about President Clinton, unlike some other presidents I have heard of, is President Clinton really understood statistics. That's a good thing. When I vote, if they know statistics, that's actually a plus for me, because that means they understand good research and good science. And to me, that's kind of important. They don't have to be an expert in statistics, but they at least have to listen to it and listen to people who understand it. So let me show you what they showed him. Okay, and I'm not sure if you know, but Clinton was like an engineer. I mean, he was a really sharp science guy. Most people don't even know that. He didn't major in, you know, a soft thing. He's majored in like hard science. Okay, so you should be able to see this. This is what they presented to him. Notice that it ends around the turn of the century, because that's when he looked at it. And what they showed him was this picture, basically. And again, I've cut it off at when he saw it. And what they were able to say is, if you look at the data, hopefully you can all see the data, that there's a trend. Do you all see a trend, Tammy and Joy? Okay, yeah, there's a trend. Now, this is a trick question. Is it an upward trend or a downward trend? Okay, so Joy, you missed what I just said. It's a trick question. Got to be very careful. Okay, it's a downward trend. Okay, even though it's a trick question. And again, this is what they show Clinton. And notice the number line. Notice the y-axis. You have a 15 on the top, 40 on the bottom. So as time is going, the clarity is going down. Okay, again, that's tricky. I wouldn't do that to you on a test, by the way, because I think that'd be too tricky. But it's the way UC Davis, and UC Davis, they are the main researchers of Lake Tahoe. And one of the things that I really was happy, I talked to the people who did this. They were up here doing some kind of science event. And I got to hear about what these things were. Now, Tammy, you might have a chance, Joy, you probably don't. But these little white things actually mean something. You know what they are? They're Cichidux. So they're little white plates. Okay, they're little white plates. And what they do is they drop it down in the water, and they see how far they can see, and they mark the length that they dropped it down when they stop being able to see, the moment they stop not being able to see. And they do that on clear days, by the way. So they make sure the weather's good. And what I've found out from them, and this really made me smile, these individual, you know, each year you'll see one of these discs on this marked chart. But this is not one boat going one time, dropping the disc down and looking. Any guess on what they do? How they get this number? Each of these numbers? Okay, what they do is they go multiple times. And this is what made me really smile. Any guess on how many times they go per year? According to the UC Davis guy? 31. It was even more LOL. They told me 31. I laughed so hard. They took my class. So they actually make sure that each of these represents an average of 31 somewhat randomly selected days. So because of that, what do we know about the distribution if you choose 31? Yeah, normal. Which means that we could do what's called regression analysis. If you don't have a normal distribution, it's not very good. Okay, at least has to be approximately normal, not to be perfect. And again, that could be a normal distribution because you did a sampling, and each dot is a sampling. What I have found is most people who do regression analysis do it wrong because they have individual points, they have no idea what the distribution is, and they just go with it. And it's not, they blow it in the mouth. But UC Davis didn't, they did it right. Okay, the other thing you want to look at is, can I draw a line through all these points? What do you think, yes or no? Okay, you said sure and yes, but the answer is no. Okay, there is no line that hits every point. I challenge you to find a line that hits every point. Do you agree with me on that? So you can't find a line through every point, which is pretty much going to be true. Ah, no, lines are straight. That's part of the definition of what a line is. Yeah, that comes from basic math, is that a line is straight by definition. It has a constant slope. Yeah. What you're thinking of maybe is a curve. A curve doesn't have to be straight, but a line is straight. But what you can do, and let me draw one, and I'm going to do my best. That wasn't too bad. Okay, is you can draw a line, and it doesn't hit every point. There's some points that it doesn't hit. Do you agree? Okay, but the points are not that far from the line. Do you see that? If you look at how far the points are, they're pretty close. It's a tight fit. Any questions so far? So that fit, that tightness of the fit, there's a measurement that talk about how tight the fit is, and at the same time, is it going up or down? And that measurement is called the correlation, which I can actually draw. Might take a while because I'm doing it with a mouse. Trying to remember whether there's 2 R's in correlation or not, but I never would test you on spelling on the regular test. I think there are. Okay, so that's called the correlation. The letter we use for that is R. Maybe because there's 2 R's in correlation. Honestly, I think it's for regression analysis. I think that's the reason why they use the letter R. So the correlation will tell you how good a fit the line is and whether you have a positive slope or a negative slope. So in particular, R is always between -1 and 1. Any questions on that? That's a good question. Why? And that would be probably a month or 2 to explain. I'd have to teach you some very serious calculus first. So I'm not going there. Is that all right? Yeah, I can only do so much. I understand it, but it is a lot of calculus to understand all this stuff. So we're not doing that. But what we can do is, you can believe me. If R is either close to -1 or close to 1, so far from 0, then we say that we have a good linear fit. If R is close to 0, then there's a very poor linear fit. Any questions on that? Okay, and that's really important. So if you have an R of, say, this R, what do you think this R might be? See if you can guess. What number might this R be? Okay, think about it. You can at least make a guess. And Joy, you can guess too. Okay, R has to be between -1 and 1. It can't be 25. Does that make sense? Because R is always between -1 and 1. Okay, so one thing I mentioned, and again, it's tricky, but we already talked about it, is this is a negative slope. Do you agree? So that means R better be negative. So R in this case is around -0.95. These points fit really closely to that line. Do you agree? You don't have to like make it up to see a line. You don't have to be like on some kind of hallucinogen drug to say, oh, I see a line. It's really clear, isn't it? I had no problem saying I can draw a line. Okay. Whereas if you look at the night sky, and those are your points, what do you think R is for the night sky? Yeah, it's really close to 0. Okay. Although lately there is no stars in the night sky, it's just cloudy or snowy. But the night sky is more of a close to 0 R. Is that clear? Okay, so the other thing you can do is we can look at this line, and now we got to bring in a little algebra. What two main things tell you about a line? What are the two numbers that you think of when you think of a line? Think in algebra. Algebra words that you learned about lines. Very important. It's been a while. Tammy? It's been even longer? All right. Slope and y-intercept, does that ring a bell? Yeah, so those should be the two numbers that come to your mind when you think of a line. There's the slope and the y-intercept of a line. So those have meaning. One of the things that, especially probably when you took math, okay, or when I took math, when I took algebra the first time, you just threw x's around and played around, probably didn't find much meaning to it. You just did that. Sound right? Okay. Nowadays, when they talk about Common Core, this is what they do. This is Common Core, by the way. Middle school, they're doing exactly what we're doing right now. Yeah, I agree. It's much better. A lot of people don't like it, but I think it's much better because it has meaning instead of just throwing around x's. But we want to bring meaning to it. So let's do a little computation. Notice that in, let's say, 1970, it was about maybe 29. So 1970. The y value is 29, which is the lake clarity. Okay, and by the way, that's how far down you can see. That many, these are in meters. Okay, that's a long way, by the way. You know, that's like 90 feet down. On the other hand, in the year 2000, it looks like it was around 19. You see how I came up with that by looking at just the line? Any questions on those 2 points and how I got them? Okay. Now, got to reach way back from when you did algebra. How do you find the slope of the line? See if you can tell me. You don't remember? Yeah, good. Joy remembers. Rise or run. How much was there a rise? Notice we went from 29 to 19. 10, actually negative 10, because it went down. Any questions on that? How much was the run? Yeah, the run was 30. So our slope yeah, you could get it. It's actually negative though. Takes me forever to write with this something. Is about equal to negative a third. Any questions on that? Okay. So now we want to look at that slope and give it some meaning. So again, it's the rise of a run. The rise is how much the lake has increased in clarity. And the run is years elapsed. Any questions on that idea? So we can see, based on this fraction, for every, and I like to write it a little differently. I can write negative 1/3, but I can also write it as negative 0.3 or so over 1. 1/3 is about 0.3. Okay, and the reason I like to put it over 1, because then I could say 1 means that the year has elapsed 1, so 1 year. Any questions on that? So what we could say is that for every year, on average, there tends to be a drop in lake clarity of about 0.3 meters. Is that good? Yeah, that's bad. Notice a couple things. One, hopefully this should be an easy one. What year are we in now? Yeah, 2019. Okay. So since this measurement, if things continued as they were, then if you look to see how much more time has elapsed since 2000, that's 19 years. 19 years times 0.3 is 5.7. You could either stick in a calculator or believe me that I did it in my head, right? If you drop 5.7 from our lake clarity, which was this 19, you get 13.3. Okay, that's a big drop in lake clarity, and 13.3 meters is not very clear at all. Any questions on that? All right, so now it's time back to the historical story, which really happened, because my student served Bill Clinton his lunch. She was working at the restaurant they had this at, and she got to serve him lunch, which was pretty cool. So she got to see it, so I know this really did happen. What discussion do you think happened? What do you think they decided on after Bill Clinton was shown this graph? And unlike some other presidents I've heard of, Bill Clinton listens to statistics, believes in science, and took action based on what the science said. So what action do you think he might have taken? Yeah. So based on this, over $100 million was budgeted to reverse the trend. Any questions on that? So again, this will tell you what will happen if nothing else changes. If you change things, then the line no longer predicts anything because now you've changed. And they did change things. They passed all these laws to help make the lake clearer. I'm not going to get into all the science, but I actually got to help with it a little bit. And you could probably guess what my job was. Any guess? Yeah, but in particular, the statistical analysis. So I actually went and I helped the Forest Service in some of the efforts that they were putting in to preserve the lake. And that was my job, was to basically, I did what I'm doing to you guys. I graded their work. I looked at their report, just like you're doing for your project, and I told them what they needed to do to make it statistically correct. Okay. So you read Call to Clarity, 2008, 2009. Exactly. Things were really changing. Okay. Okay, but much earlier, actually. It's when Clinton came in when everything changed. So I figured I should show you what it looks like. Okay. Again, now that Clinton did that, he put in hundreds of $millions in. Hopefully, if you spend that kind of money, something good might happen. Do you think it happened or not? Okay, you want to see? I got to reshare my desktop, and now you get to see the rest of the curve. That is that one. All right. Can you see that? Oh, good. So now we see up to now. Notice between 2000, that's when the things were changed, and 2019, what do you notice about the clarity? What do you see? It's curving back, but more importantly, it's not going down anymore. Okay, it goes up and down. So I want to mention something. Even before, okay, even in the early days, you see there were times when clarity got better. If you look between, say, 1983 to 1987, clarity got a lot better. Do you see that? Okay. So, and the reason is that there's a lot of things going on. There's both what we're doing as people, the population destroying lake clarity, but then there's also weather. So there are a lot of factors involved in lake clarity. Does that make some sense? This decline happened because of people, but there were ups and downs that happened because of weather. Okay, in fact, my guess is that lake clarity for 2019 will probably go down because I know you're not up here, but if you're at, but you probably know because you're all living in California, what's been happening in California in the last 4 or 5 weeks or so. Yeah, we're having crazy weather, and all of that erosion is going to happen and put dirt and stuff into the lake. Okay, and you can't stop that. Okay, that's going to happen. What you can stop is automobile stuff going to the lake and other things that happen. So the human part of it. So there are different causes or factors involved in lake clarity. So the next statistics I want to mention is called R squared. And the funny thing is, I remember when I took statistics, it was the mathematical statistics. The professor did a whole 1 hour lecture on showing that the way to get R squared is you take R and multiply by itself. It took an hour to do that. So I will tell you there's a lot of depth involved in doing what seems really obvious, that R squared should be R times R. But it's actually a lot more than that, and you just got to trust me on it. There's some serious math. So again, what we can say is that there's different things going on. I'm going to look again between 1968 and 2000, before Clinton came in and made sure we made the big change. It's not a perfect fit, but it's a pretty good fit. If R was, say, 0.92, then what's R squared? I bet you can do this in a calculator. So if R is actually negative 0.92, What's r squared? The negative doesn't matter when you're squaring it. So it's 0.92 squared. Yeah. And what you usually do is you think of that as a percent. How do you turn that into a percent, whole number percent? What does that become? Yeah, in particular, what do you get? Round to the nearest whole number percent? Yeah, 85%. R squared is 0.8464, and then multiply by 100%, round to the nearest whole number, and you get 85%. Any questions on that little bit of math? All right, so here's what that means. If you look at the years between 1968 and the year 2000, that's what we were focused on, then the spread of the data is pretty big, right? It goes all the way from 31 was the best late clarity, and the lowest was down here, maybe down here actually, and that looks like, the lowest is over here, which looks like 19. So there's a spread of the data that goes from 19 to 31. Okay, more specifically, you could look at the standard deviation of the y values on this curve. And there's a pretty big standard deviation. Do you agree? Okay. But if instead of, not sure, how do you know? Oh, well, because it spreads between 19 and 31. That's a big spread. Big spread means big standard deviation. And it's not like there's just one outlier at 19 and one outlier at 31. It's all spread out. You see that? So there's a pretty big standard deviation for these, for just the data. On the other hand, if you look at like clusters, just clusters over the years, so I think I can do that. Let me go annotate. Just grab some clusters. Now, if you look at each of these clusters, they don't vary that much in terms of late clarity, just by a few. Do you see that? So if you look at all the clusters and you look at the standard deviation for all the clusters, and you average them, the standard deviations, it'll be about 85% less than the standard deviation without focusing on years. So what you can say is that about 85% of the variation is attributable to elapsed time, right? The fact that we're getting worse and worse when it comes to polluting our lake. And 15% of the variation is for other causes like weather. %, less than, yeah. So that's a kind of a simplistic way of looking at it. It's good enough. So if you look at the spread from 19 to 31, that is what, 12? And if you take 85% of 12, or 15% of 12, I guess, because that'd be 85% less, would be, let's see, 15% of 12 would be about 1.8, which is a much smaller spread. Okay, so if we take away the time elapsing, then we have a 85% reduction in the standard deviation of the spread. So that's usually a good thing when you're trying to predict things. Okay, if there's no reduction, then the whole line is useless. But having an 85% reduction is a big reduction. Any questions on this idea? For most people, that's the hardest idea there is in terms of this chapter. Any questions? Okay, I think I want to do an example that is not as exciting as this one because This is my favorite example because I live in Lake Tahoe and this is our big thing. And this is real. So let me give you more of a fictitious example, more that might look like a homework kind of problem, but also really important. So let's go ahead and let me go there. Let me give you one with data. Okay. So is what you just did looking at the data, yeah, that's all called regression analysis. Okay, and in this class, we only do regression lines. So we did the best fitting line. Does that make sense? So we look at regression lines, but in the real world, you do regression curves. You might look at best fitting parabola or best fitting logarithmic curve or best fitting exponential curve. Does that make sense? And in fact, you probably heard of something called artificial intelligence. I'd say 90% of that is regression analysis. Is the computer looks at data and then looks at how good a fit different curves are, fits the data with the curve, is very complex, by the way, and then uses that to make predictions. Just like we made a prediction about what the lake would look like if we didn't have Clinton doing what he did. Okay, that's how artificial intelligence works. Okay, whether it's face recognition, it looks at data points on the face and looks at data points of other faces and see which is the best fit. Very similar kind of stuff. We're not going to go anything that complex, but you could believe me that it is the big thing right now. So we're just going to do some regression analysis on linear regression with standard data, not a million data points, but enough that we can put it in a calculator by hand, for example. Okay, so the data below show the results of a study of 9 community colleges done that looked at the percentage of students at the community college who received financial aid and the percent who were business majors. We want to conduct a hypothesis test for the correlation and then perform a full regression analysis. Any questions so far? Okay, so when you perform a hypothesis test, this is new for us, what we want to do is we want to see if there's a correlation. By the way, if there is no correlation, what is the correlation if there's no correlation? It's an easy answer if you think about it. Yeah, 0. So what we want to do is we're going to start out, as you're used to, with an H naught and H1. So here's a harder question for you. It had nothing to do with math. Okay, you're used to, like, we use S for standard deviation, and then we use the Greek letter sigma, which is like a Greek S for the population standard deviation. Remember that? Same thing, we use the Greek letter mu. So the correlation is R. That's a sample correlation. Do you know the Greek letter for R? Let's see if anyone knows. Told you that's a hard one. It's not a math question. It's a Greek question. Give you a moment and then I'll type it in. We're getting some no's. That's okay. But you will know it by the end of within a minute or so. So we're going to have an H naught. You're used to this. This shouldn't be new at all. And a colon. Now the new part. The Greek letter for R is? Anyone know what that is? Okay, it rhymes with what you wrote. It rhymes with no, it's rho. So you pronounce it as rho. R-H-O is how you pronounce it. Is how you spell it in English. So rho equals 0. Looks like a smiley face with a tongue sticking out. Never heard that one before. Sounds good though. Okay, and then we want to see if it's equal to 0 or not. And then we're going to have an H1. Rho is not equal to 0 because we want to see, is there a correlation? And if there is a correlation, then rho is not 0. So the good news is that whenever you're doing a hypothesis test for regression analysis, it's this. Okay, the 0 means that there's no correlation, right? If rho is 0, then there's no correlation. Remember night sky? That was the rho was 0. So that means knowing the y coordinate, knowing financial aid, knowing the financial aid percent tells you nothing about how many business majors there are. Does that make sense? On the other hand, if rho is not 0, then financial aid is a good predictor for how many business majors there are, okay? And that's what we're interested in. If we fail to reject the null hypothesis, then you shouldn't do regression analysis. Because if there's no correlation, then what's the point of trying to make a prediction? The slope is worthless, everything's worthless. Okay. Oh, I didn't mention in the last example, why did I not mention the y-intercept? Because that's the other biggie in lines. There's a reason I didn't mention it, but I want to talk about why I didn't mention it. There is. Every line has a y-intercept unless it's vertical. Okay, so the y-intercept, what is that in math? What does that mean to be the y-intercept? What's the value of x for the y-intercept? Zero. Okay, now remember that x represented the year. Okay, and you may not know, Tammy, you do because you've lived here. And Michael, I'm not sure, have you lived in Tahoe or you live in Tahoe? You never lived in Tahoe. Okay, but what was Tahoe like in the year 0? What were all the people doing around here? Okay, there were no people here. You couldn't live in Tahoe in the year 0. It was way too cold. Imagine trying to live in Lake Tahoe in that time without technology. Yeah, so there were no people. It doesn't even make sense to talk about what Lake Clarity was due to people in the year 0. Do you see that? It is so far from all the data, you don't even go there. Does that make sense? Okay, but let's look at this. I just wanted to mention that because that was something I forgot to mention when we talked about it before. So sometimes the y-intercept is useful and sometimes it's not. That was one where it's not. It's not useful if it makes no sense to talk about x equals 0. Also, sometimes it makes no sense to talk about the y-intercept's y value. Like if you looked at the y-intercept's y value, you would have gotten something like, 1,000. And why does that make no sense? I think it would have been more like 3,000. Okay, remember what the y was. That was how far down you could see. Well, do you think you could ever see 3,000 meters down? No, because the lake isn't even that deep. It's a deep lake, but not 3,000 meters. Is that clear? So that's another reason sometimes that the y-intercept is not useful, is if the y value just makes no sense. Okay, in that case, it would make no sense. So it's either that the x value makes no sense, the y value makes no sense, or the data is nowhere near 0 for the x values. Okay, so now the next thing I need to do is we need to learn how to use a calculator. So do you have your calculators with you? Okay, so the good news is that the beginning looks really similar to what you've always done. What have you always done when you had a table like this? What do you always start with your calculator? So I'm going to share my calculator. Find it. I have so many things open. There it is. Okay. Let's clear what we had. Let's quit, actually, wherever it was. That was last week. So what we do is we go to Stat, and then you go to Edit. Right? You always put into L1 and L2. Isn't that what you do? Okay. Except for chi-squared, we use matrix sometimes. But otherwise, we've always done this. And then we clear out L1 and L2. And then we just type in our numbers. So we had 42 and 38. Then we also had 56, 19, 40, 37, 72, then 55, 20. That was L1. Okay, so our financial aid. L2 was business major, 15. Oops, 15. And then 17, 7, 34, 12, 15, 6, 9, and 27. Any questions on entering the data? All right, so now that we have our data entered, then we're going to do what we're used to. We go to the Stat button. I'm going to go to Tests. And now we're towards the end of the class, right? There's only, really, next week is our last week of new material, and there's not even that much next week. So that means at the bottom. So I'm going to use the up arrow to get to the bottom. And it's actually almost the bottom. It's linreg t-test. Any questions on that? I hit enter. X list is L1, that's good. Y list is L2, that's good. Freq is always 1 in our class. We want a not equal to, so I hit enter on not equal. Don't worry about reg EQ. Any questions before I hit calculate? Okay, so I hit calculate, enter. Okay, now I want to give you some bad news. You're used to equations of lines, y equals mx plus b. Isn't that what you're used to? I'm sure that's what you learned, right? Okay, here's the bad news. In regression analysis, we don't use those letters. B is actually the slope. Sorry. Don't shoot the messenger. It's not just the evil Texan people. This is what everyone uses. There's a reason, but it's high level, and I can't explain it to you. So it's a plus bx. We have a t-value. That's the test statistic. Turns out it's the same curve as the t-test that you did a long time ago. Again, there's some deep math behind it. We don't do that. The p-value is a p-value 5.02. Right, definitely not. It can never be bigger than 1. It's got that e negative 4, so it's 0.0005. Yeah. DF is degrees of freedom. That always comes up, but we're not doing much with it. B, that's important. That's our slope. B is negative 0.50, negative 0.5 about. S we're not going to deal with in this class. That's a little more advanced. I'm going to hit the down arrow to get some more stuff. R squared is 0.84. R is negative 0.92. A, by the way, was 36.9 or about 37. Any questions on this? Okay, so now I'm going to go back to where I can start typing. And let's do all of our analysis. So let me go and new share. Came out different? Uh-oh. Shouldn't be any different if I typed everything in right. Well, we'll just use the numbers I've got. And then I apologize if I have a typo or something. You guys didn't tell me, but that doesn't mean it's not, my fault. Okay. Oh, you got the same as mine. So Joy, I think you made a mistake. It's hard to know exactly what it is. All right, so now we had our p-value of 0.0005. You should all know what that means, what that tells you about our H0 and H1. So tell me what that means. Yeah, statistically significant. So let's write this down. There is statistically significant evidence to conclude that there is a correlation between the percent of financial aid students and the percent of business majors. At colleges. Any questions on that idea? Okay, so I'm going to do some more stuff. Let's take a look at the slope. Remember the slope? Not sure if you remember, but if you got it in your calculator, it's still there, was b negative a half, negative 0.5, or 0.5 over 1. So let me remind you. So the slope. I like to write the word slope because if I write b, that confuses everyone. Okay, so I like to put it over 1 because slope is rise over run. We want to write it as a fraction. It's easier to interpret it that way. So remember, slope is rise over run, the change in y over the change in x, or how much business majors percent changes if you change by 1% of financial aid. So let's write this out. So what we can say is that for every additional percent of financial aid recipients a college has, there tends to be a decrease of 0.5% or 0.5%, use the word percent, of business majors. Any questions on that? Okay, so does that mean that if we go to a college like LTCC and we decide to give, just going to donate a whole lot of money to the foundation so that a whole lot more people can get financial aid, does that mean that because of that, there's going to be fewer business majors? What do you think? Okay. What's wrong with what I said, Tammy? Yeah, the key word that I used was because. And the word because has cause in it. And correlation is can never just be directly interpreted as a causation. So be careful. Do not say that if we increase financial aid majors, financial aid recipients, that will result in dropping financial aid majors, because that's not necessarily true. Okay? So be careful about any language that even applies causation. Don't say that if you give more financial aid, then you're going to have fewer business majors, because that's a causative. Notice the words I used. There tends to be a decrease. You could also say that we predict a decrease of. That we can say. But you can't say cause. Any questions on that? Okay, it's a big error. It's a big error that I see, and I will let you know. I always test on it on the final exam. And you will have the opportunity to demonstrate on the final exam that you know that the verbiage of regression analysis should not have cause in it, or because, or if this happens, this will happen, or this made this happen. That's all cause verbiage. Okay, instead, you're going to have tends to happen, predicts to happen. Does that make sense? Okay, really important. Okay, and I will test you on it. So again, it's your chance to get lots of points. Okay, or you could just like not think about it and lose points big time. So you choose. Okay, so I want to look at some more stuff. Okay, let's look at the y-intercept. Was about 37. So let me write that down. Okay, so now, yeah, 36.875, I rounded. You usually want to round for real, if you're going to start interpreting things. Does it make sense to have 0% financial aid? Could that happen? Yeah. Not too common, but some of these for-profit colleges, for example, will have a 0% financial aid because they don't get to give they don't get to have government help because they're this for-profit stuff. So that happens. There definitely are some. Does it make sense to have 30%, 37% business majors? Could that happen? Yeah, that could happen too. So the y-intercept is actually something we can talk about. Do you see that? It's a little suspicious because there's no really small financial aid data, but we can still have it. So what we can say is that the best prediction for colleges with no financial aid students. Is that it will have 37% business majors. Any questions on that idea? Okay, so the next thing I want to do, there's a lot of stuff we can do, by the way, is let's interpret R squared. Okay, so if we want to interpret R squared, notice, by the way, R squared was about 0.84 or 84%. So let me write that down. All right, so now we can interpret it. There is a large variation in business majors that colleges have. Okay, that's pretty big, right? We see there's a 6%, there's a 34%, pretty big variation. If we just look at colleges with a fixed financial aid percent, then the variation will be decreased, will on average be decreased by 84%. Okay, so we could say that, sorry, I wrote 85%, I meant 84%. Let's fix that. I need to hit, sorry about that. My mistake. %. That's better. Any questions at all on that idea? Any questions? Okay, so there's some more stuff we can do. Regression analysis is a pretty big field. We can look at R. R, by the way, was negative 0.92. Notice it's negative. Okay, the slope will always have the same sign as R. So we could say that R has a negative slope, a negative sign, so the slope is negative. Do you see that? We could also say make a prediction. I could ask you, what do you think? What's your best prediction for a college with, let's say, 30% financial aid? What's the best prediction for business majors? So to do that, we need to do the following. We first get the equation y is equal to a plus bx, and that was 37, plus b, which was negative 0.5, so minus 0.5x. And typically, shoot. Let's try something. Got it. Computer was being mean to me. We put a hat over the y. And we say the predicted value of y is 37 minus 0.5x. So that's a standard notation for regression analysis. So the good news is predicting is pretty easy. If we want to predict 30%, then all we do is put in 30 for x. And we can say y is equal to y hat equals, and write HAT is equal to 37 minus 30, negative 0.5 times 30. What's that equal to? I can do that one in my head, actually. You get 22. Yeah, so I get 22. You can put in your calculator, you can do it in your head, whatever works as long as you get 22. And that's our best prediction for the percent of business majors at a college that has 30% financial aid recipients. Any questions on that idea? So there's a lot to this. You notice there's a lot of details. That's why I gave you full regression analysis, did a lot of stuff. Okay, at least full for what we're doing in our class. All right, let's see. I don't have a lot of room, but I need to put it somewhere. Maybe if I do it in red down below. And that is a secret word. Make it bigger. And the secret word of the day is prediction. Because we use the regression line to make a prediction for a value. I always try and make my word meaningful. Okay, any questions at all? I think I'll stop the share. Any questions at all about anything? This is your chance. By the way, next week, I want to make a good time for the webinar. It's a review for the final. Okay, I'd love to take requests, so post in the Q&A forum if you have a requested time. Otherwise, it might be like usually an evening at the beginning of the week, like Monday or Tuesday evening. It can't be too late because some people want to take the final early. So it should be at least by Wednesday. But if you have a specific time, I can be flexible. But I haven't gotten a lot of requests. So I've been back and forth on Mondays and Tuesdays. Anything about the project? What date is the final due by? The final is due 16 days from today, which is the 27th of March. You like Mondays, okay. If I don't hear anything else, it'll be Mondays. If I hear other people, a whole lot of people say they like it Wednesday, then we'll do that. Tuesday, uh-oh. It's a tie. Ties are hard. I'll see how it goes. And either for Joy. All right, maybe some people will post that are watching this and couldn't make it. Joy said Tuesday. Joy said either. I can read. It's still there. Okay. Well, I'll say good night to you also, Tammy. Any questions, Miguel or Joy? Okay, well, thank you guys for coming. And next week will be the last webinar of the entire quarter. So be ready for it. It's an important one. Okay, and for all of you who are watching this as an archive webinar, thanks for watching. Make sure that you post on the Q&A discussion forum or the project discussion forum if it's a project-based question. And I look forward to reading your rough drafts in the next few days. So take care. Bye.